Hello and welcome. Let's continue our lesson. And before we start the lesson, if you have any question or comments on my previous videos, please add them to the comment area. I will answer those questions in during one of the lessons, or I'll record a separate video for that. Okay. In the last video, I gave basic building blocks of an intelligent system, or let's call it system going forward. And those components were, first was a CPU section, CPU or CPUs. Second one was IO controllers. Or sometimes we also call it peripherals or peripheral controllers. And third component was accelerator. And now we want to create an actual hardware with these components. So we want to develop a PCB. Let's pick a different color for that. Okay, let's get the boundary of our PCB. By the way, PCB stands for printed circuit board, and you have seen it inside laptop, desktops, or mobile tablets. There is an electronics board which has different components on it, different chips on it. Our basic building block was the one we started with, was a CPU. So let's see, we buy a chip from a vendor which has a CPU or has different CPUs. Okay. Then the system we are developing needs to have a couple of USB ports. And for each USB port, we need to have a USB controller chip that we buy from another vendor. Okay, let's say we have two USBs. So this chip that we have two copies of it. Assume we need an HDMI port as well. For that we would need an HDMI chip or controller from maybe same vendor as this one, but maybe another vendor. Depends on the different features of that chip. Okay, let's see what else we can have. Let's see, we have a hard disk, external hard disk, and we want to have a hard disk controller chip. We have a VGA, so we need a VGA controller chip. Let's say we also have a PCI interface that we connect this PCB onto a motherboard, and for that we need a PCI or PCIe controller chip. Okay. We can have an external SRAM that we connect to. Okay. And for that we will need a memory controller or DDR controller. Okay. And all these controller chips will be connected to their ports as well as to the CPU. These are all the peripherals, controller chips, the CPU chips, and we also talk about an accelerator chip. Okay, which may be connected to some external, but main interface will be the CPU. This accelerator chip can be a processor, a very dedicated processor designed for an application, or we can have an FPGA chip. FPGA stands for Field Programmable Gate Arrays. The future of these chips is that they have already built a generic hardware, and you can program that hardware um, on the fly even after the chip is made, and you can have some dedicated hardware for different applications, and you also have the flexibility of changing that hardware. For example, if you have your own hardware and you want to upgrade that, you want to bring some more features, so you don't need to buy another chip. If you had an FPGA that was capable of taking your new hardware, then it's no extra cost. Now, this PCB or this system created in this way has several disadvantages. One of them is that it's a pretty large area. You have discrete components off-the-shelf components. I mean, they're already built by different vendors. To put all of these in a PCB, you need different chips, and that increases the size of this PCB. Now, maybe for some applications or some areas, this PCB with this big size might be a good one. But as we have seen that overall the size of the systems is shrinking, and so this large area definitely has issues for those applications or for small form factor systems. Because of large area, because of different kind of chips, we have higher power. Each one consumes a power, then current flows through these circuits back and forth to the IOs. So overall, you have a higher power. Then, as I mentioned, you're taking components from different vendors. Let's say for worst case, 1, 2, 3, 4, 5, 6, 7, 8. You take chips from 8 different vendors. The chip that you take from a VGA vendor, he's pretty good at VGA chips, but he's not good at others. You have to deal with different vendors. Now, sometimes they might have some dedicated interfaces or dedicated features in some of these that you might have some compatibility problems, and you have to do some extra work to make them compatible. The Other problem you can have are, um, you know, what if a vendor stops creating the version of the chip that you have? Now you want to create more PCBs for more customers, and the problem is that now that vendor is no longer producing that chip, and the vendor has created another chip with more features in it, but you don't need all those features, and you don't want to consume larger area, okay? Because it's going to disturb your PCB. You have to design a new PCB, you know, another version of your PCB for something that you don't want. Okay, so all kind of those issues. Speed can also be an issue since uh, the communication between different chips or different uh, peripheral chips and CPUs, or it is all through these circuits or metals on a PCB. They are slower. They're slower than the interconnect you have within that chip. So the transistors are sitting on a chip, and when they talk to each other, they have lot more layers. Their distance is a lot smaller. So overall, lot less capacitance, resistance, or less speed, less power compared to what we have outside. Now, for some application, in the area that you want to develop this system for, maybe that's not a problem, or maybe you're using a lot of peripheral that are slow speed, so you don't care. So that can happen too. Depends on the application. Okay, let's create another version of this PCB. Let me go down a little bit. And what we do is we try to reduce area. Okay. We okay. Oops. That's not pen. This is an eraser. Okay, let's go back to the pen. Okay. So similarly, we buy a CPU chip from, oops, I think it's pen, but okay. Sorry for this. Let me fix this problem. Okay, hopefully this is better. Okay, that's good. So we buy a CPU chip from one vendor, and we create our own chip, or we buy from a vendor with all the IOs and IO controllers that we need. For example, Intel calls it a peripheral controller hub. So let's call it PCA. This has USB, hard disk controller, HDMI, PCI, VGA, all those things. And then for accelerator, we still use a separate chip because our expertise are not to. Our expertise are not in that area, so we still prefer a vendor chip for that. And we create a PCB for this. So this new system has 3 chips. So still have all the different IOs that you need, which need to be connected. This need to be connected, this need or this need to be connected. But overall you can see you have much smaller area that will make your system have lower power, lower speed, and you don't have to deal with like 10 different vendors. You have to deal with 3 vendors, or maybe you create one of your own chip with um, the controller that you want. And one other advantage that you have is, which I didn't mention previously, which I forgot to mention, the fifth disadvantage with this system of large number of off-the-shelf or different vendor chips is security. Okay, because anybody can purchase your PCB and figure out what different components from what vendors you have used and can easily copy your recipe. You don't want that. And in this case, okay, it's still possible that CPU, PCH, and accelerator, but it will be a lot better for security and for the rest of the things. Maybe you have created PCH chip yourself, and only you know what kind of components you have in there. So it's good. It's better than this one. Now what we can do is we want to make it even smaller because because size of the systems is getting smaller, and we want to get a benefit of smaller area to smaller power, higher speed, very few vendors, security. What we do is let's pick another one. We create single chip. Okay, PCB around it. Now within this chip, inside this chip, we have a PCH piece, we have CPU piece, and we have even accelerator. We brought that hardware onto the same chip. Now if this was an FPGA, if we created fabricate a dedicated hardware, we cannot change it, so it will not have the advantages of an FPGA. But people are also looking into bringing a programmable FPGA type functionality on a chip, so that a component or a block within a chip you can program. So this is like one chip system or system on chip, on a single chip. Okay, so that concludes our first chapter, which was what is an SoC, what are different building blocks of an SoC. The next videos we will further look into how we will design an SoC, and our focus will be more on the physical design of an SoC. Okay, so thank you so much. Take care. Bye.